Here we're looking at solving simultaneous equations algebraically. So this is where we have two equations with two unknowns. To begin with, we are going to make one of the terms, either the x or the y's, to have the same coefficient in front of them. I'm going to start by looking at making both the 3x term and the 2x term of both equations to have the same coefficient. In order to do that, I'm going to find equivalent equations to each of these. So first of all, equation 1 and equation 2, which I've labeled here, I'm going to multiply equation 1 on both left-hand side and right-hand side by 2. And I'm going to multiply equation 2 on both left-hand side and right-hand side by 3. This will ensure that I get this 3x term and 2x term to be 6x for both equations, i.e. I have found the lowest common multiple for both 3x and 2x is 6. So that's what I'm going to try and get them to first. So multiplying both the left-hand side and right-hand side of equation 1 by 2 gets us 6x plus 10y is equal to 8. Multiplying both the left-hand side and right-hand side of equation 2 by 3 gets us 6x minus 3y is equal to 21. Now that both of my x terms on both equations are the same, I can start by doing something to both equations. I can subtract or add one equation to the other, and this is based on the principle of balancing. We know that 6x minus 3y, so 6x minus 3y here, is exactly equal to 21. So if I was to take 6x minus 3y away from the left-hand side of the equation, that is also the same as taking away 21 away from the left-hand side, from the right-hand side of the equation, because they are both equal values because of the equal sign in between them. So essentially what I'm doing is I'm actually taking away the same thing from both sides. Now I'm going to take away this equation from both sides because that will result in my 6x being eliminated. So let's look at how we would do that. What I would do is I would write down subtract between each term. So first of all, I'll look at this term here, and it's useful to put that subtraction in the middle so we can see whether there are two minuses in certain cases. The middle terms that we're going to be subtracting is 10y minus 3y, and this is where a lot of mistakes are made. So always circle them in the way I'm doing, boxing them, just so you can see which term take away which term you are doing. So let's do 6x take away 6x, nothing. 10y minus 3y. Since we have a minus, we've got that becomes a positive, so we have 10y plus 3y, which becomes 13y there. And then we have 8 take away 21, which is minus 13. Now that we've got an equation involving only one unknown, we can solve this by balancing. So we're going to do the same to both sides. We're going to divide by 13 and divide by 13. That leaves us with y is equal to minus 1. So we have found out what y is, but we need to go back and find out what x is. So start with any of the equations from anywhere. So I'll start with the first equation, 3x plus 5y equals 4. And now that I know what my y value is, I'm going to substitute that in. 3x plus 5, lots of minus 1. There's my substitution. Always have substitutions in brackets, is equal to 4. This now becomes 3x minus 5 is equal to 4. Ask ourselves what's happened to x. Well, x has been multiplied by 3 and then minus by 5 to equal to 4. So let's plus 5 to both sides, and that would get us to 3x is equal to 9. And then let's divide by 3 on both sides, and that gets us x is equal to 3. So we found that the answer to this is x equals 3 and y equals 1. What does solving linear simultaneous equation actually represent? So we found the values of x and y, but what do they actually represent? Well, let's take a look at each of the equations that we have from the beginning, and let's draw them on this xy grid. So first of all, 3x plus 5y equals 4. If we were to draw that, well, let's find out where it crosses the x-axis. It crosses the x-axis when y is 0, so 3x is equal to 3x plus 0 is equal to 4, therefore x is equal to 4 over 3. So the coordinate that we have here is 4 over 3 and 0. Likewise, let's go and find out where it crosses the y-axis by setting x to 0, and that would give us y is equal to 4 over 5. So 0, 4 over 5 is the second coordinate. So let's go and put that in. 4 over 3, 0. And 0, 4 over 5. And then if we were to join these up using a straight line, then we would then have the equation of the line 3x plus 5y equals 4. Let's just label that 3x plus 5y equals 4. I can do a similar thing to draw the other line, 2x minus y equals 7. This one I'm going to draw slightly differently. I'm going to rearrange and make y the subject, so I'm going to have 2x minus 7 is equal to y, and so I'm going to do it through the method of y-intercept is minus 7, so 0 minus 7 is one of my coordinates. And we can find out where it crosses the x-axis by setting y to 0, and that's 7 over 2, somewhere along here. So now that I have my two coordinates, again, I can do a similar thing. I can join them up using a straight line. And there I have my straight line, which is for the equation 2x minus y equals 7. So what does solving simultaneous actually, how is it linked to the graph? Well, what we've actually found when we've solved the simultaneous equation is the point of intersection of the two lines. So this value of y equals minus 1 and x equals 3 would be exactly the same as this coordinate of the intersection. Intersection coordinate. And what is that? Well, obviously we can't really read off this because it's not a very accurately scaled diagram that I've drawn. But what I wanted to represent here is that solving simultaneous equations gives us the intersection of the two equations that we are solving. So in this case, 3 minus 1 that we found is that coordinate of the intersection.